Okay, good morning students. So today we shall be doing few problems on vectors. Let's say this is the first problem. Uh, at takeoff, a helicopter rises 15 meters while moving north 8 meters and west 6 meters. How far it is from the starting points? It's a very good problem. So let's coordinatize the systems first. So suppose this is the height h, this is x and this is y. Suppose this is x, this is y. Okay, so northeast, west, south. So if this is north, this is west. Okay, and this is the vertical direction. So it says that helicopter rises 15 meters. So if I coordinatize, suppose this is as x, this as y, and this as z. Okay, so the unit vectors along x, that's I cap. So I can see that the position vector of this helicopter, suppose this helicopter is here. Okay, suppose this helicopter is here. Helicopter may not have 5 blades, never mind. Suppose this is the helicopter. Anyway, so suppose this is its position. Okay, and we are joining this to this, and this is our position vector r. So now r, I can say that it has gone 15 meters, right, times k cap, because the height is 15 meters, right, plus it has gone north 8 meters, so 8 I cap plus 6 meters along west j cap. So that's all. So this is the expression. So how far is from the starting point? So that's mod of r. That's the required thing. So 15 square plus 8 square plus 6 square, 225 plus 64 plus 36. So this is 100. 325. Oh, sorry, you have to give a root. So this is 11 times 25 to the power half, so it's 5 to 11 meters answer. Okay, great. Okay, this problem is also related to components. See, compute the resultant of the following system of coplanar forces, the angles being given with respect to x-axis. So it's first is 3 into 10 to the power minus 10 Newton, 10 to the power, minus 4 Newton, 4 into 10 to the power minus 4 Newton at 30 degrees, and 4 into 10 to the power minus 4 newtons as at 150 degrees. So I think if these are coplanar forces, so let's coordinatize in a two-dimensional plane. So that's the plane of the board. Suppose this is our y-axis and this is our x-axis. Fine. So this is x, this is y, and let's draw the vectors. So all starting at this origin O, and first one is 3 into 10 to the power, so yeah, so this one, this yellow one, so it's at 0 degree, 3 into 10 to the power of minus 4 Newton. I told you there is a scale. Suppose if I divide this, suppose exactly the scale should be like this. While drawing vectors, you must give a scale, right? Suppose this or a little bit, yeah. So this length, right? This length represents 1 into 10 to the power of minus 4 Newton. So 3 times this is an approximate scale just to make you understand what exactly it is. So this is the scale. Okay, this is the scale. Never mind. So let's go. Now it's 4 into 10 to the power minus 4 Newton, 30 degrees. Great. So 4 into 10 to the power minus 4 Newton, 30 degrees. So increase a little bit, and I hope this is 30 degrees. So this is 4 into 10 to the power of minus 4 Newton, and this is 30 degrees. Next is 4 into 10 to the power minus 4 Newton, 150 degrees. So total is 180 degrees. It should be exactly this way, right? The magnitude is the same. So this is 4 into 10 to the power of minus 4 Newton, and this is 150 degrees. This is 150 degrees. Okay. Now we need to get the resultant of these three vectors. By best way to do is just take the components, right? Best is to take the components. Do one thing. If this is 150 degrees geometrically, this is 30 degrees, or you can directly use 150 degrees, that is all the same. Let's name the vectors. Suppose this is vector A, this is vector B, and this is vector C. Let's name them. So A has a component, so A vector has no y component, so that is 3 into 10 to the power minus 4 I cap. That's all. B, yeah, B has a x component as a y component, so it is 4 into 10 to the power minus 4 cos 30. Okay, I cap plus 4 into 10 to the power minus 4 sine 30 j cap. So you can express it like this: cos 30 is root 3 by 2, 4 into 10 to the power minus 4 into root 3 by 2 I cap plus 4 into 10 to the power minus 4 into half j cap. So that is 2 root 3 into 10 to the power minus 4 I cap plus 2 into 10 to the power minus 4 j cap. That's B. Now C. C is, you can take directly 150, that's all the same. So it's 4 into 10 to the power minus 4 cos 150. So that's the anti-clockwise direction. You must give a degree, sorry. So 150 degrees I cap plus 4 into 10 to the power of minus 4 sine 150 degrees j cap. Okay, so cos 150 is minus cos 30, so that is minus 4 into 10 to the power of minus 4 cos 30 I cap plus sine 150 degree is plus sine 30, all sine time cos, second quadrant sine is positive. So 4 into 10 to the power of minus 4 sine 30 degrees j cap. So this is equal to cos 30 is again root 3 by 2, but it should be minus. So minus 4 into 10 to the power of minus 4 into root 3 by 2 I cap, very similar to this, plus 4 into 10 to the power of minus 4 times half times j cap, right? So this is minus 2 root 3 into 10 to the power of minus 4 I cap plus 2 into 10 to the power of minus 4 j cap. Now let's add them. So resultant is a plus b plus c. Very simple, very simple. You can do it easily. A is 3 into 10 to the power minus 4 I cap. So this is a plus b 2 root 3 into 10 to the power of minus 4 I cap plus 2 into 10 to the power of minus 4 j cap plus minus 2 root 3 into 10 to the power of minus 4 I cap plus 2 into 10 to the power of minus 4 j cap. Okay. See, this 2 automatically gets cancelled. This is the plus I cap term, and this is the minus I cap term. This term gets cancelled. Both are I cap, and this I cap is left as it is because there is no I cap term, and these two will be added up. So it will be 3 into 10 to the power minus 4 I cap plus 4 into 10 to the power of minus 4 j cap. Okay, so you can represent it back in this original way how it is given. So it is 3 times this and 4 times this. So this is the let's say this is as r. So r vector is this. So magnitude of r is 3 plus 4 whole square, so that's 5 into 10 to the power of minus 4. Okay, and newtons. So this is also Newton. And angle with the x-axis, so theta is tan inverse 4 into 10 to the power of minus 4. 10 to the power of minus 4 gets cancelled, so no need to write that, so by 3. So that's angle with x-axis. I recommend you to always take a frame, represent all the vectors in components with respect to that frame, then add the components. That's the best way to do it. You will not make any mistake. Fine. Another point I want to mention, the c vector, you can also write it as x component as 4 into 10 to the power 4 cos 30, but then you have to write as take the unit vector as minus j. It is directed minus j. So this c can also be written as as 4 into 10 to the power of minus 4 cos 30 times minus j cap. Okay, so plus 4 into 10 to the power of minus 4 sin 30, sorry, I cap, minus I cap sin 30 j cap. So this can be also written This is very similar to this and this are the same. So this and this are the same. Whichever you prefer, it's not a problem. So you can easily drop components here and here. So this is the x component, this is the y component. So x component must be multiplied with the unit vector minus I cap. So if you take it at as cos factor. So keep that in mind, and I hope you enjoyed these problems. Let me go to the next problem. Well, this is a typical problem for changing the momentum. This you can also do it with the help of vectors. I want to show you. Suppose this is a wall. Suppose this is a wall. Okay, and a particle hits the wall like this, and it's rebounds back in this fashion. Fine. And suppose this is the angle theta. The initial momentum is P1 and the final momentum is P2. So what I want to tell you is, please try to do the force exerted on the wall. Please try to do this problem with the help of vectors. Means I want the force exerted on the wall. Let delta t be the time of collision. Actually, this is not a problem, this is a way of solving it. What I want to ask you to do is, I shall not go into the problem. What I ask you to do is, take this as the origin, this as the x-axis, this as the y-axis. Now resolve this P1. Resolve this P1 in terms of P1, the x component times I cap, plus P1 y component times j cap. Also resolve P2, whatever it is given in the problem, P2 x component times I cap plus P2 y component times j cap. Now if you are asked to find the change in the momentum, so that is automatically P2 minus P1. Okay, and force exerted is, suppose this is delta P vector, so force exerted vector is equal to delta P by delta. So that is rate of change of momentum. So what I tell you is, try to use components of vectors, express them in components of some unit vectors. That will help you a lot. And one thing I want to tell you is, the components are not necessarily in the I cap j cap direction. They may be in some different direction as well. Let me help you with another problem. So let's do another problem. So this is another problem. See, I cap j cap are the unit vectors along x and y axis respectively. What is the magnitude and direction of the vectors I plus j and I minus j? What are the components of the vector A along this direction I and I plus j and I minus? So let's find the magnitude and direction of I plus j and I minus j. Mm, let's concentrate on this problem first. This problem we'll do it later. Okay, let's coordinatize the system first. This space is enough, I think. So suppose this is the x-axis and this is the y-axis, and I plus j, you understand I plus j is, suppose this is I, so this is I am expanding a little bit so that you will see it properly, and this is j. Suppose this is I and suppose this is j, right? So I plus j is 45 degrees. The magnitude. So magnitude of I plus j, it's very easy. You square the components coefficients and add them and take a root. So it's 1 square plus 1 square to the power of half, that's root 2. Okay. Also magnitude of I minus j is absolutely the same. It's 1 square plus minus 1 square to the power half, so that is also root 2. So the direction of I plus j is, let me draw a circle, it will help you. Let me draw a circle. Okay, so the circle has the same radius, so the circle has a radius of let me increase the circle a little bit. The circle has a radius of root 2. Okay, circle has a radius of root 2. This has a magnitude of 1, so the circle has a radius of 1.414, so a little less than 1.5. So I think you understand this. So this is the vector. Okay, this is the magnitude of this vector. This is it should be a little less. Let me first use the square. Sorry. Yeah, that should be I plus j, correct. Geometrically that should be I plus j. Yeah, that is correct. Now, so this is I plus j, right? So geometrically this is I cap plus j cap, and very similarly to the minus j I cap minus j cap. So minus j cap will be in this direction, right? So this is minus j. So this is minus j. This is minus j. This. Okay. So again, if you touch this, right, so this is I cap minus j cap. Fine. The magnitudes are and the direction is, you need to find these angles. These angles are all 45 degrees. So 45 degrees. This is also 45 degrees. But the thing is, for the second one, you should give a negative anti-clockwise direction. Right. So I plus j direction (45 degree) with x-axis, and direction, so 315 degrees with x-axis. Whenever I say the degree, it is basically with the in the anti-clockwise sense, so 315 degrees. Now the question is, they're asking what are the components of A along this and along this. So let me do this problem first. This is a very interesting problem. I need more space, so let me delete this. I'm not deleting it actually, I am preserving it, then I'll do it later. Sorry. Now let's find the components. So this is the second part. The second part we are doing what are the components of A. So what is A? A is 2I cap plus 3j cap. Now what they are asking is basically they are asking the components of A along the unit vectors along I cap plus j cap. So let's find the unit vectors first. Unit vectors along I cap plus j cap. So that is I cap unit vector. So vector or unit vector. It's not a plural, it's singular. Okay. So I cap plus j cap divided by magnitude of I cap plus j cap. Magnitude of I cap j cap we've already found out. So I cap plus j cap by root 2. Say this is as E1 cap. Say. So unit vector is E1 cap. Now unit vector along I cap minus j cap is, suppose say this is E2 cap. So E2 cap is equal to I cap minus j cap by magnitude of I cap minus j cap. This also has a magnitude of root 2. So this is I cap minus j cap by root 2. Now let's express this in terms of this. Okay. So it's A is equal to some constant A. Suppose A times I cap plus j cap by root 2. So what I mean to say is A should be written in this form: A times E1 cap plus B times E2 cap, right? So this is E1 cap, this is A E1 cap plus B times E2 cap is I cap minus j cap by root 2. Okay. So this is, what is the coefficient of I cap? This is A by root 2 plus B by root 2 plus j cap plus A by root 2 minus B by root 2. Now let's take an equation. See, this must be equal to 2I cap plus 3j cap, right? So this implies that A by root 2 plus B by root 2 must be 2, and A by root 2 minus B by root 2 is equal to 3. So these are the two equations. You can solve it simultaneously. If you add them, this B cancels, so adding. So adding, suppose this is equation, let me name them. This is equation 1, this is equation 2. Then if you add them, adding gives you, adding 1 and 2, 1 and 2 gives you, so 2a by root 2, so that is root 2a. Root 2a equals to 5, implying a equals to 5 by root 2. And if you subtract 1 minus 2, and subtracting 1 minus 2, you get b terms survives. So there is root 2b. Root 2b is equals to minus 1, implying b is 1 by root 2. So what is the a vector? What will be the a vector then? So a vector will be, just plug in the coefficients. See this, plug in this coefficient, check this term. Plug in this coefficients. A is how much? 5 by root 2 times e1 cap minus 1 by root 2 times e2 cap. Okay, and here writing it here as well. 5 by root 2 times e1 cap minus 1 by root 2 times e2 cap. So keep this in mind. This is a very important thing. You can choose any basis. That is not important, and you can represent any vectors in any basis, just that the dimensions must match. If you are choosing another basis which has a higher dimension, suppose this vector is represented in R3 basis x, y, z, so there will be no k components, but you can write it keeping the component of k as 0, and at least the dimensions must match, so that you can represent any vectors in any dimension. Okay, this is very important. Let's do, I think I have done a few more lot of problems. You can try few other problems as well. Okay, let me see. See, what I tell you is the unit vector video. Check the unit vector video. It is very, very, very important. Check the unit vector video and try to express vectors in terms of unit vectors. Unit vectors are the greatest advantage. They do not carry a dimension. All the dimensions are carried by the constant which is in front of the unit vector. I hope you enjoyed this video, enjoyed these few problems. I shall do few more problems as we carry on along with this course. Thank you very much.